I've installed the Hyper-V module, and if I check the module path environment variable, you can see that the installation has added this folder onto the normal module path for PowerShell to go and load modules from. Now if I look in that folder, you'll see there's a subfolder called Hyper-V, and that subfolder's got a manifest file that's also called Hyper-V. So when I call it import module, that's what gets loaded, and I can check the commands that are loaded with get command. Now the module version of this library supports online help, and you can see I can use -, I can use get help, and I can use get help with the different switches like -examples or -full to see some more information. And you can see we've got examples of how to use new VM, we've got detailed information about each of the parameters, and we've got other sources of reference like where to go and look on MSDN for details of the WMI objects being used. So I'm going to go ahead and create a new virtual machine, and I've assigned the resulting virtual machine to this variable $VM. You can see what's in $VM, it's an object, and I can pipe that object into set VM memory, or I can pass it as a command line parameter to set VM memory. And just to show you, PowerShell is very flexible when we pass command line parameters. If we put them in the right sequence, we don't have to specify the switches to say what they are. I can use the same process for setting the CPU count and for setting boot order and a comment on the virtual machine. If I come across to the graphical interface, you can see here's my freshly created virtual machine, and if I look at the boot sequence, that's what I just set. The memory is what I set, the CPU count's what I set. Haven't added any hard drives or DVD drives yet, and here's the comment that you saw me set a moment ago. I want to add a network interface to this virtual machine, and I want to specify when I do so which switch it's going to be connected to. Now get VM switch will give me a list, select VM switch will prompt me to select if there's more than one. So on this machine it's just going to return the one available switch, and when I do add VM NIC as I'm doing here, my one and only switch will be connected to my network card. Hyper-V deals with disks as both drives and disk images, so I'm going to create a hard disk drive and a DVD drive. So the next step is to create a virtual hard disk. Get VHD default path tells me where that will be created by default, and I'm going to specify a new VHD. Hyper-V will assume that path and the VHD extension. I give it a size, and if it's going to be a fixed disk or a differencing disk, I have to specify that. I'm just going to say wait because I don't want this to run as a background task. Two commands to show you quickly here. Get VHD gives me a list of virtual hard disks, and get VHD info tells me about them. So I need to mount something into those drives to actually give me the disks. So the first thing I'm going to do is to mount my newly created virtual hard disk into my virtual hard drive, and now I'm going to mount my local DVD drive into the logical optical drive on that machine. And you can specify the drive letter for an optical drive here, and you can see the connection looks rather strange. It actually is the device ID for the drive object on the host machine, and here is how you discover that if you need to. So you can get the WMI object and then its ID. So let's pop over to the graphical interface and just have a look at those changes. So if I go to settings, you can see that my hard disk, my DVD drive and my network card are all set up. New in this version is the ability to get a script that describes how the virtual machine is built, and I can see that there, I can save that, and now I'm just going to start my virtual machine and open a session to it with VM Connect. The number that comes back there is the process ID in case you need to refer to it in the script, and as you can see it's booting from the CD drive. I'm not confined to working on the local machine with this module though. There's a utility called getVMHost that will query Active Directory to find out which machines have registered that they're running Hyper-V. You can see the list of machines here, and I'm running on the machine called Gromit. As you can see, if I do getVM and specify a server parameter, we can query another machine, we can start virtual machines on that server and do all the things we'd expect to do, but specifying which server. I can get a remote virtual machine and assign that virtual machine to a variable, and then I can use it in exactly the same way that I was using the local virtual machine earlier on. In fact, I can even use a command where I combine the local and remote virtual machines in a single command like this. So that's very useful, but PowerShell version 2 has got its own built-in PowerShell remoting. Now, first of all, you have to enable PowerShell remoting with this command here, and once you've done that, you can see I'm getting a PowerShell session from my machine Gromit onto the computer called Wallace, and if I do enter PS session, it's almost like having a telnet session or a remote shell session into that machine. So I can run a command, I can see what modules are available, and I can drop out of that session just with exit PS session. Now that's useful, but that's not the best thing about PS sessions. The best thing is they remain around when you're outside the session, so we can run a command in that session. So what I've just done is remotely run import module Hyper-V in my PS session, and if I go back into it, you can see that the module is now loaded, which it wasn't before, and I can run a command from the module like getVM, and when I've done what I want, of course, I can just drop back out and I can be active in the session on my local computer again. Now that's useful, but it becomes even more useful when we use the switch as job, and now it will run as a background job. We can query the state of that job, and you can see the state is currently running, and if I query it until the state changes from running to completed, you can see that we've now got some information that says this job has more data. You can see has more data equals true. I can receive that data. If I don't specify the keep switch, it will clear the data off. So you can see now if I do get job, has more data has changed from true to false when I didn't use the keep switch. Sometimes we won't want to use jobs, we'll just bring the data straight back, like the getvhd command, and that can be piped into a local command. If I look at the functions that are available to me, you can see the module hasn't been loaded on this computer, and if I do a quick count of the functions, you'll see there are only about 37 of them. There aren't the 100 odd that are part of the module. Remoting gives us a trick for adding local functions to do remote tasks. So if I do import session here, I want you to ignore the errors that come up. I'll explain why we get those errors in a second. If I go back and look at the functions, you can see that all the functions in the module have been added, and I can run getVM, but it runs against the remote machine. One important thing to point out here is the class of the object has changed. It's got this word deserialized added onto the front, so anything that's looking for this class name may come unstuck, but all the property names we'd expect are there. This changing the object class means that I can't do the normal piping that I do, and instead what I have to do is to pass the names of virtual machines rather than the objects that represent them. And you can see here I'm getting the names, and for each name that I get I'm invoking suspend VM. One last thing to show you in a fresh PowerShell session is running that import command slightly differently. We can avoid it having to deal with clashes between the remote machine and the local machine, and we've specified a prefix, so now I can use get Wallace VM to be clear which machine I'm running on.